Yellowstone National Park, the northeast part of the park, overlooking the Lamar Valley there. And I am high on Specimen Ridge, a really unique part of the park that has this interesting story with these amazing petrified trees cemented in place. This one here is maybe 6 feet or so in diameter, just an enormous specimen. We can actually see a little bit of the full diameter of it up here. And then there's two more down here sticking out that we'll go look at. Let's start with the context for how these trees came to be here and what these rocks have to tell us. If you look at this outcrop here, you'll see just a jumble of rocks of different shapes and sizes. Not much layering. There's some kind of crude layering in there, but just kind of a hodgepodge mixture of rocks of different sizes and shapes. This is a unit known as the Absarica volcanics. It's Eocene. It's about 50 million years old. And this goes back to a time before Yellowstone as we know it was here. There was a different volcano here. There were high volcanoes to the east, a chain of volcanoes, big stratovolcanoes like you'd see in the Cascades, other sorts of volcanoes. And these big mountain volcanoes would shed off lahars at times. So there would be these volcanic mudflows that would come down the flanks of these mountains, perhaps from melting of the snow and ice, perhaps just from rain and flooding events. But that would mobilize all this material as a slurry down into the lowlands, where in places they completely encased these large trees. We're going to walk down the trail here and get a better look at it. There are some pieces as well that are horizontal. So here's a piece of a petrified log that's sitting here horizontally. But this tree is still vertical as it once was. We can see some of the root splaying out down here. We're going to walk down underneath this thing. But the eruption of the Absarica volcanoes just shed all sorts of debris into the lowlands. We know based on looking at these trees, the trees up here on Specimen Ridge, I hear there's dozens of these, and they vary from various types of conifers to deciduous trees. And they all indicate that the climate was much more temperate, so warmer and wetter than the Yellowstone we know today. Here's that same tree up here, and here's sort of its root ball. We can see some of this, again, this lahar material, just big blocks, maybe ash cementing some of this together. Here's some of the root of the tree. And unfortunately, this specific petrified tree is probably doomed. This gully and the erosion here is kind of undercutting the rocks beneath the root ball. And so at some time in the future, this thing will tumble down the cliff. There's a bedded unit over here that looks like it's probably a tuff, like a layer of ash that erupted in between these lahar events. We'll walk down a little bit further to these two. The footing here is not optimal. And we've talked before about how these petrified trees form. But the idea here is that we've got trees growing. They get buried either in a lahar deposit or maybe ash. And then as they're buried, groundwater circulating through the wood actually replaces all the organic material, essentially cell by cell, with silica, with basically quartz-rich material. So this one here is maybe about 8 feet tall, maybe 2 feet in diameter. That one's about the same. These ones look like they're in a little better shape in terms of not sliding down the hill. So yeah, so we see some of these still upright, some of these laying on their sides. And just here you can see some of the mineralization, this quartz-rich mineralization. This is moving along some sort of seam. So there's some sort of fracture here. Looks like where groundwater's moved through it and precipitated out some really pretty white quartz material. One more big log down here sticking out of the hillside. This one's probably a little more than 2 feet in diameter. And you can see the, it still retains the actual grain of the bark, the texture of the bark itself. The colors come from various impurities in the quartz, in the silica as it moves through. So this one's a little more iron rich here. This one's got a little more white to it. It's interesting because, I mean, when you touch this thing, it still feels like wood, but it's actually stone. So it's pretty impressive that the replacement here is so delicate that it can actually retain the complete fiber and characteristics and texture, if you will, of the wood itself. So anyway, Specimen Ridge and the Ipserica volcanics, this just hodgepodge mixture. This is similar to, if you watched my video from Malm Gulch in Idaho, this is similar age, similar volcanic processes. So we can see that event in the Eocene that was erupting volcanoes in the western US extended here to northwest Wyoming, into parts of southwest Montana, and into parts of central Idaho, as well as in addition to some other regions as well. So I'm gonna start heading down the nasty slope down to the cars in the highway there. Some bison out there in the valley, little black dots. Yellowstone National Park, Specimen Ridge, petrified trees and wood in the Ipserica volcanics.